You are elbow deep in the engine bay of a project, maybe wrestling with the rusted suspension of an old BMW E36, or trying to bring a classic Peugeot 205 back from the dead. You have your breaker bar out, your knuckles are already bleeding, and you are fighting a lower control arm bolt that feels like it has been permanently welded to the chassis by Mother Nature herself. You are sweating, you are frustrated, and you know that if you put just a few more pounds of force on that wrench, the bolt head is going to snap right off, turning a simple weekend driveway repair into an absolute nightmare of drilling and tapping. We have all been there. But what if the solution to this specific nightmare and half a dozen other crippling automotive problems was sitting in a blue and yellow can on your garage shelf right now? Most drivers look at that can and just think of it as a generic squeak silencer for a house door, but they are completely missing its true mechanical potential. When used correctly, this engineered fluid can save your engine, protect your electrical systems, and cut your repair times in half. Today, we are taking a deep mechanical look at exactly how to utilize this formula to pull your car out of some of the worst situations imaginable. Before we get into the heavy mechanics of saving your vehicle's sensitive electrical network from catastrophic water damage, if you want to keep your garage skills sharp and save serious money on repairs, take a quick second to hit that subscribe button. To really understand what we are working with, you have to look at the name itself. The 40 in the name actually stands for the 40th attempt at creating a specific formula, and the first part literally stands for water displacement. Back in the 1950s, aerospace engineers were desperately trying to figure out a way to protect the massive metal outer skins of rockets and missiles from rusting and corroding while they sat on the launch pad. They did not need a heavy grease. They needed something that could aggressively push moisture away from a surface at a molecular level. That exact same aerospace chemistry is a lifesaver for modern cars. Today's vehicles are rolling computer networks. They are packed with complex wiring harnesses, weather pack connectors, and sensitive sensors communicating in milliseconds. Usually, these connections are totally sealed, but if you decide to aggressively pressure wash your engine bay, or if you accidentally blast through a deep puddle of standing water at 40 miles per hour, high-pressure water can force its way past those rubber silicone seals. When water gets trapped inside an electrical connector, it bridges the gap between the metal pins. This causes instant short circuits, massive voltage drops, and throws your engine control unit into a panic, often resulting in a car that stutters, stalls, or refuses to start completely. If you pull a sensor connector apart and see water inside, you need to flush it out immediately before green copper corrosion sets in. By spraying a quick burst directly into the connector, the fluid actually undercuts the water, breaks its surface tension, and physically pushes the moisture out of the plastic housing. Because the fluid itself is non-conductive, it will not cause a short circuit. It leaves a microscopic protective film behind that lets the metal pins communicate perfectly again. Now, keep in mind that this film is incredibly thin and will evaporate over a long, hot summer under the hood. So, for a permanent fix, once the connector is totally dry and clean, you should always pack the inside with a thick layer of dielectric grease. That heavy silicone grease will create a waterproof barrier that lasts for years, keeping out road salt, moisture, and dirt. Speaking of electrical nightmares, let us talk about the heart of your starting system, the car battery. If you pop the hood and look at your battery posts, you might see a thick, crusty, white and blue powder growing all over the metal terminals. That is copper sulfate, and it is caused by acidic hydrogen gas venting from the battery and reacting with the copper in your cables and the moisture in the air. This crust is a massive electrical insulator. It creates a physical wall of resistance between the battery and the starter motor. You get in the car, turn the key, and all you hear is a rapid clicking sound, or worse, absolute silence, even though the battery itself is fully charged. You have to eliminate this corrosion. First, you always disconnect the negative terminal, then the positive. You grab a wire brush and a simple mixture of baking soda and water, and you scrub the metal until it is completely bare and shiny. You dry it off thoroughly, but if you stop there, that white crust is going to return in a few months. This is where you create a chemical barrier. Before you bolt the terminals back on, give the bare metal posts and the cable clamps a light coating of the spray. The fluid acts as an oxygen and moisture barrier. Since corrosion requires oxygen, moisture, and acid to grow, taking the moisture and air out of the equation completely stops the chemical reaction. You bolt everything back up tightly, and you have ensured maximum cold cranking amps can flow to your starter motor on those freezing winter mornings. Now let us go back to that rusted suspension bolt we talked about at the beginning. Underneath your car, you have a brutal environment. Components like exhaust manifold studs, brake caliper brackets, and lower control arms are subjected to extreme heat cycles, freezing road spray, and highly corrosive road salt. Over years of driving, the steel oxidizes. The rust physically expands, essentially locking the threads of the bolt to the nut. It becomes one solid piece of useless metal. If you just grab a wrench and pull with 200 pounds of force, the bolt will shear. Instead, you need to rely on capillary action. You take your spray, utilizing the little red straw for pinpoint accuracy, and you soak the threads heavily. The solvent carrier in the formula is designed to be extremely thin, allowing it to wick deep into the microscopic pores of the rust, carrying the lubricating oils with it. You have to have patience. Let it sit for at least 10 to 15 minutes. Let the chemistry do the hard work. When you come back with your wrench, you will feel the friction has been drastically reduced and the bolt will break free cleanly. If it is still fighting you, give it another heavy soak, tap the head of the bolt with a hammer a few times to send shockwaves through the rust and break the bond, and try again. Not only does this save the fastener, but the residual oil left behind helps prevent new rust from forming on the exposed threads. But what happens when the problem is not under the car but right under the hood, and it threatens your safety on the highway? Your hood latch mechanism is located at the very front of the vehicle, right behind the grille. It is constantly bombarded by rain, dirt, and road grime at highway speed. The secondary catch, which is the safety hook that stops the hood from flying up and smashing your windshield if the primary latch fails, relies on a simple metal spring. Over time, all that dirt mixes with old grease and turns into a thick, sticky concrete. You pull the release handle in the cabin, but the hood refuses to pop up. Or even worse, you close the hood, but the latch does not fully engage, leaving you driving at 65 miles per hour with a hood that could fly open at any second. You need to blast that entire latch assembly to break down the hardened grease and dirt. The solvents will cut right through the grime. Use a flathead screwdriver to manually work the latch jaw back and forth, simulating the hood opening and closing while continuing to spray. You will literally watch black, gritty sludge drip down. Once the mechanism snaps back freely and the spring feels tight and responsive again, wipe away the excess fluid. The latch will operate as smoothly as the day the car rolled off the assembly line, keeping you safe on the road. If you have a dead misfire after a massive rainstorm, this next trick is going to save your ignition system. But right before I explain exactly how to flush that water out and bring your engine back to life, make sure you are subscribed so you never miss these critical garage hacks. Water and high voltage are terrible enemies. Whether you are driving an older car with a traditional mechanical distributor and spark plug wires, or a newer vehicle with coil on plug ignition, water intrusion will shut you down. If you drive through a flooded street and water splashes up into the engine bay, it can seep into the distributor cap or down into the deep spark plug wells in the cylinder head. The ignition coil is trying to send 30,000 volts of electricity to the tip of the spark plug to ignite the fuel. But electricity is lazy. It always takes the path of least resistance. If there is a trail of moisture on the ceramic body of the spark plug or inside the distributor cap, the high voltage will follow the water right to the metal engine block, completely bypassing the spark gap. Your engine will misfire aggressively, lose all its horsepower, and run incredibly rough. You pull the distributor cap off or pull the ignition coils out of the head, and you lightly spray the inside of the cap and the rubber boots of the wires. Just like with the electrical connectors, the fluid displaces the water, breaking that conductive path to the ground. You wipe it dry with a clean shop towel, put everything back together, and the spark is forced to jump the gap at the plug again, restoring your engine to perfect running condition. Just remember, this is an emergency water displacement trick, not an engine oil substitute, so never spray it internally into the engine cylinders expecting it to act like motor oil. Moving away from the engine, let us address something that drives every driver crazy: the squeaky, groaning car door. Every time you open or close the door, you hear a loud, embarrassing creak that sounds like a haunted house. Most people assume the hinges are bad, but the noise usually comes from the door check strap. This is the metal or plastic arm that runs between the door and the frame, holding the door open at different angles so it does not swing back and hit your leg. It is under heavy spring tension, and when it gets dry and covered in dust, rest, the friction causes that terrible groaning noise. Spraying a little bit of fluid directly onto the pivot pins of the hinges and heavily along the sliding arm of the check strap works wonders. Open and close the door a dozen times to work the lubricant deep into the internal spring mechanism. The noise will vanish instantly, and the door will glide open with zero effort. That same principle applies when winter hits hard. Imagine walking out to your car on a dark morning. The temperature is hovering around 0 degrees Fahrenheit, and you are freezing. You pull the door handle, and nothing happens. The locking mechanism inside the door has completely frozen solid because moisture from the afternoon before seeped into the lock cylinder and turned to ice overnight. It is a miserable feeling. But because the fluid actually lowers the freezing point of water and displaces it, you can shoot a quick blast right into the keyhole. It will immediately begin to melt the trapped ice and push the moisture out of the tumblers. Wait a few seconds, gently insert your key, and the lock will turn smoothly. You can even take a clean rag, spray it heavily, and wipe down the rubber weather stripping around the door frame before a big winter storm. This creates a hydrophobic layer that stops the rubber seals from freezing to the metal door frame, ensuring you can always get into your vehicle no matter how bad the blizzard gets. Finally, we have to talk about the very tools you use to work on your car. If you have spent good money on high-quality ratchets, sockets, and wrenches, leaving them in a humid garage or a damp basement is a death sentence for the metal. High-carbon steel loves to rust. You might reach into your toolbox after a few months of not turning wrenches and find your favorite chrome sockets covered in a fine layer of surface rust. To prevent this, every time you finish a big job, take a few minutes to maintain your tools. Lay them out on a towel, give them a very light mist of the spray, and wipe them down with a microfiber cloth. You are not trying to leave them dripping wet. You just want to leave a microscopic barrier on the metal. This thin film seals out the humid air and moisture, ensuring that your expensive tools remain perfectly smooth, rust-free, and ready for action for decades to come. So, from pulling your electrical network back from the brink of a water damage death, to breaking loose the most stubborn rusted bolts and keeping your expensive tools shining like new, you now have the advanced mechanical knowledge to use this simple can like a professional technician. Do not let these common problems cost you hundreds of dollars at a repair shop when the solution is already sitting on your shelf. Drop a comment below telling me about the worst stuck bolt you ever fought or the weirdest electrical gremlin you had to track down in your own car. Let us talk about those nightmare repairs in the comments. Make sure you hit that subscribe button one last time, and I will see you on the next repair project.